This one's for all the people who messaged me their feedback. Thanks very much.
Start taking notes.
So for those back in on Monday, social distancing explained. 2 meters for geographers is one ranging pole. A ranging pole is a 2 meter long pole that you can use to stick in the ground and to measure angles between points at equal heights or to identify distances. It's got the red and white lines on it so that you can pick exactly the same point on two separate ranging poles when using a bit of kit called a clinometer to measure the angle of the slope between those 2 points. Interesting stuff. Link to the Do Now quiz is on ePraise or in the description. Pause here and get it done. Answers already on there. So, a few bits of feedback related to the Do Now quiz and key bits of geographical understanding that we need to get right. On a hydrograph, the precipitation is shown by the bars, and the point where the bars are highest is known as the peak rainfall. Afforestation, we need to make sure afforestation and deforestation are linked to rates of interception. Afforestation, more trees, means there's more interception. The trees are stopping the rain from reaching the surface, therefore slowing down surface runoff. Deforestation means that there's less trees, so therefore there's less interception, increasing rates of surface runoff. Being able to make those connections is really key to explaining deforestation as a cause of flooding and afforestation as a type of flood management. And you need those keywords interception and runoff in order to explain that fully. Lastly, the Cumbria Flood Action Plan did include afforestation, and that was the thing for that question 10 from yesterday that was really important that we got right and that 6 of us didn't. We identified that dams and reservoirs weren't used, and some of us identified that flood walls and dredging were used. 6 of us thought that afforestation was not used. Now, either you didn't read the question right or you don't know that case study well enough, so it's worth going back to it and making sure you're getting that right. And now we're going to go back to something that should have been covered yesterday but wasn't. We should have spoken about the fetch of a wave yesterday. It's an easy concept, but it just wasn't mentioned. I forgot. My apologies. The fetch is the distance a wave travels before hitting land, and we can demonstrate that via this map of the UK. The UK there in the east of this map has to the west the Atlantic Ocean and to the east the North Sea. Waves travelling across the Atlantic Ocean have travelled a huge distance before hitting land, so therefore are likely to be stronger. And if you go to the west coast of the UK, down to say Cornwall, you're going to see big waves. To the east of the UK is the North Sea, and waves travelling across the North Sea haven't travelled anywhere near as far, so therefore they're less likely to be as powerful. And if you go to the east coast of the UK, the waves are not as powerful as the waves on the west coast. That is due to the fetch, the distance a wave travels before hitting land. Should have covered it yesterday, didn't. Apologies. So today we're going to look at another couple of processes that affect our coastlines, and the first one we're going to talk about is weathering. Weathering is the breakdown of material due to mechanical and chemical processes. Mechanical, in this case, due to changes in temperature, and chemical due to the chemical composition of water. Mechanical weathering involves no chemical changes. Chemical weathering clearly involves chemical changes. What I would say is people often get confused between weathering and erosion. Weathering is when the material is broken down where it is and it doesn't actually then end up being carried away. Erosion is when material is broken down and carried away. So these things are different. The first type of weathering we're going to look at is mechanical weathering and changes in temperature resulting in freeze-thaw weathering. When it rains, water gets into cracks in rocks. If, typically overnight, the temperature drops below freezing, that water then freezes within that crack, and when water freezes, it expands, it gets bigger. That expansion of the water within the crack exerts a force on the crack and pushes outwards, causing the crack to widen and to deepen. That process will repeat again and again and again, night after night. Every time there's water in these cracks in the rock and the temperature drops below freezing, this process will happen until eventually rocks at the coast will be broken apart. Chemical weathering, in this case carbonation weathering, is when acidic rainwater and acidic seawater affect certain types of rock, such as limestone. The reason that it's called carbonation weathering in this case is because limestone contains calcium carbonate. The acid in the water dissolves the calcium carbonate from the rock, therefore weakening and breaking down the rock via carbonation weathering. So there's our two types of weathering. We're going to move on now and we're going to talk about processes of mass movement. First type of mass movement we're going to look at, rockfall. Fragments of rock that have been weathered have been broken down due to mechanical weathering, processes of freeze-thaw, or that have been weakened by chemical weathering, the dissolving of calcium carbonate within limestone, for example. Those weaker fragments of rock are likely to break away from the cliff face. At that point, they fall down, so rocks falling down, rockfall, nice and easy. They are then known as scree when they're found at the bottom of the cliff face. Our second type of mass movement is sliding. This is when large blocks of rock slide downhill in a single motion, a single direction along the bedding planes and along a slide plane. So when there is a single direction of movement of rock, large blocks and slabs of rock downhill at the cliff, that is known as sliding. The final type of mass movement that we're going to talk about is slumping, and that is typically when saturated soil slumps along a curved surface. So slumping differs from sliding in that when sliding occurs, the material slides in a straight line down the cliff face. When there is a slump, the material drops and then curves as it goes down. So it's more of a curved movement of the cliff rather than the straight movement that is a rock slide. So what I'm going to ask you to do for this is to produce annotated diagrams to show the following: freeze-thaw weathering, chemical weathering, mass movement, rockfall sliding and slumping. Go back through the videos if need be and listen really carefully. Then produce your diagrams, make sure they are annotated, not just drawn and labelled. Try to add short sentences to explain what's happening. When you're done, it'd be great to get a photo of those sent to me, because I can then look to include that in next week's feedback. So homework questions, knowledge organisers are as an attachment on ePraise. Get them done, because this is really good consolidation for the work that you're doing in the online video lessons.